Hello, everyone. Good morning, good evening, depending on from where you are logged in now. Thank you so much for joining in. My name is Suman Debnath. I work as a developer advocate with AWS, and I'm based out of Bangalore, India. And today, in next 25 minutes, we are going to talk about deep learning on AWS. So what we are going to see is, what is deep learning, and how you can leverage developing deep learning models on AWS. So to get started with, we know that AI is the future, and this is what the whole world is moving towards. Whether we are a software engineer or electrical engineer, or not even in the tech field, but we are using AI directly or indirectly. So what exactly AI is? So if you think of, in a very broad scale, AI is about making a system which can think like a human, right? Who can take autonomous decisions and of its own. And what makes AI to take those decisions is a set of algorithms, lots of models, and how you take all those data and learn the pattern out of it. And this set of tasks comes under machine learning. So we can think of AI as a broad field, and within that we have machine learning, which can accomplish the task that we are actually intended to. So one of the example of AI would be autonomous car or robotic cleaning machines that we have. So to achieve that, we need to build lots of models, and we need to gather a lot of data or information, and we have to understand, what those data or information means. And within machine learning, we also have a subset, and that we call it as deep learning. And this is where the crux of complex processing happens. So when we talk about deep learning, we are actually talking about problems which are very complex to solve, like image-related problems, like image classification, or analysis of video streams, or automotive car, as we have just discussed. So deep learning is about how you how you capture information from based on neural network or CNN, and it is not like you have to come up with X data and Y class labels and you will train the model, what we generally do in machine learning. But in deep learning, you don't have to tell the model that what are the features and all of that, what are the important features in the data set. So deep learning has the intelligence, and the way that the algorithm in deep learning works is it will automatically extract the information or the features from your data set. Now, if you look at the machine learning timeline, you will see that it's not something that is new. So this has been there for quite some time. So if you look at a few of the technology or algorithm like Perceptron or backpropagation, which we are going to discuss in some time. So these all were there in 1950s or 1980s, but nothing much happened after this until recently. So I guess from 2012 onwards, we again started to see a lot of traction about deep learning. But why it got stopped, all this while, and why the development was not there, so far. So one of the reason is, at today's day, right, when we talk about deep learning, everybody is working on it. We all are learning. And one of the reasons that we could able to do so is because we have enormous amount of data now, which was very much needed to build any good and robust model. And we also wanted to have good infrastructure in the form of very strong CPU or GPU systems, which we have today in our disposal. And obviously, we are now having lots of programming language as well as the frameworks like TensorFlow, PyTorch, etc. And because of all of these three, we are able to build a lot of, important and useful models which can solve very critical problems like image understanding or speech recognition and autonomous car. Right? So these things were not there in 1980s, like these amount of data and these powerful systems. And even if it was there, it was like way more expensive, right? So those are the things that made us do deep learning consumable by every engineer. Now, what is a deep learning? So if you look at a deep learning, it is basically mimicking our human brain. So our human brain is comprised of lots of neurons, and they are connected to each other. And whenever we see something, like let's say I see an image, and immediately within a microsecond or even less than that, we figured out what that image contains, right? And how we are able to see that. We're actually seeing because our neurons are getting fired in the right way, and that information getting projected in our back of our brain, and we are able to identify that. So deep learning is almost we are trying to mimic that. Okay, so, and the way that we do it is something like that, something like this. So this is the basic neuron, or we call it as perceptron. This is what was developed, and it was found in 1956, I guess. So this is a single neuron, and what we do is with this neuron, we get the input data, and we pass all this input data, and with some weights. So this input data is having n features. So that's why you see it as a xn, right? So let's say you have a data set where you have name, address, phone number, and all of that. So this x0 is nothing but, let's say, name. X1 is nothing but the address and all of that. So n features that if you have, and then what you do is you multiply all of these individual features with something called weight. So weight is nothing but we can intuitively think of it as, when we get a data set, not all the features are important. Only few features are important, right? So we might have the respective weight to be higher for features which has more influence or correlation with its output, right? So maybe this feature is very important. This X1 feature is very much important, and this X2 feature is not that important. So weight 2 or W2 would be less with respect to weight 1, but we don't know, what that weight is. So initially, what we do is we randomly initialize these weights W0, W1, W2, and Wn, right? And the whole idea about deep learning is about coming up with the right weight and bias. Okay, and what this bias is actually, you can think of it as when you try to take a decision based on some input, there is always some condition where no matter what your inputs are, you will not bother about that. So one example would be, let's say, I want to go out to play cricket, and there are a lot of dependent things that if I can go to play out for cricket, do I have necessary accessories like a bat or ball? Is it raining outside, or are my friends available? So these all are inputs, right? So, and based on that, I can take a decision that I will go out to play cricket or not. But let's say I'm sick, right? So if I'm sick, no matter what I have in the input, I will never be able to go out and play, right? So I am sick. That is nothing but a bias. So bias is something which is always try to neutralize your prediction. So a lot of models we do have bias, a lot of models we may not have bias, but this is something that we always have in a basic neuron. So we have weights and we have bias, and now what we do is we aggregate this. So this is nothing but a dot product. So what we are doing here is we are multiplying all this input with its respective weights and summing it up. And once we sum that up, what we do is we activate. So we just put that through a function. So there are different types of activation function, like sigmoid a function or ReLU, etc. But the idea about that function is to add complexity to your function, right? To your model, and based on that, it gives you some output. So the whole idea about a neural network or deep learning is to come up with the right weight and the right bias. So we keep on feeding data so that we come up with the right weight and right bias. And these are the different functions, activation functions that we can have, like sigmoid, tanh, ReLU. If you're interested, you may like to go over that. But the idea is, the function should be as should be such which adds complexity. So in real world, mostly people uses leaky ReLU or tanh and obviously sigmoid. So this is not that used, because it has a sharp edge. So we want to make a decision which has a smooth boundary like this, right? So it is not having a sharp edge. Now there are different types of deep learning models that we have. Multi-layer perceptron, CNN, RN, but we are going to talk about MLP today. So in MLP, what happens is it's exactly like what we have seen in Perceptron, but now we can think of this as, we will stack multiple neurons or multiple perceptrons, and all the input, right, all these inputs will be multiplied, by its weights, and it will be pushed to each and every neuron, okay? And all these neurons output will be fed to another neuron, okay? And that's how you get the final output, okay? So now what happens is each neuron will have its own activation function, okay? And this activation function gets activated after aggregation. So you have here you aggregate all of these inputs, and then you have some sigmoid function. Here also you might have sigmoid function, and these output goes as an input to the next layer. So these layers are called hidden layers. Okay, so now the whole idea about this is something like this. So let's say you have an image like this, which contains a digit 4, and now you want to classify that this image contains a digit 4. So we try to first go forward, and that is what we call as forward propagation. And let's say we keep on moving forward, and we came to know that the output is 5, okay, which is obviously it's not correct. So what we do is we calculate the error, right? And we see that, okay, the actual class is 4, but we got 5. That means our weight initialization was not correct. And that's when what we do is we go backward. So we go from the output layer towards the input layer, and keep on changing these weights, right? So all these points will have weights and biases. So we keep on changing them. And how we change them? We use gradient descent, and there are different algorithms that we can use to optimize. But the idea is we have to make sure that the error goes down, right? So we need to go to the local minima. Once this is done, we keep on doing this. So we keep on doing this until we get a decent amount of accuracy. And once we see that, okay, we are getting a good amount of accuracy, maybe 90% or 95%. We just freeze that. Okay, this is the final weights that our model need to make this prediction. Okay, so these loops keep on going. Now let's take this another example. So now let's say we have these numbers 0 to 9, and these are the vector notation of all these numbers. So we just converted these numbers into these vectors. And now let's say we pick this image which contains 5, right? And we pass it on to the input layer, and then we have again we have aggregation and the sigmoid function, and we train the model. Sorry, we train the model, and once it goes through, right, what we will see is in the output layer we use another function called Softmax, which is nothing but it takes the output and converts it into a probability distribution. So now we can possibly have 10 different digits, right? So we will have a probability distribution of 10 different variables, and each of them will have its own probability. So now, so that means the sum of all of these probability will be 1. So if you look at it, this is 5, right? And we see that the neuron which has 5 is having a probability distribution of 85%. So we can take the maximum of this, and we can say that, okay, the number or the image that the neural network is seeing is actually contains 5. Okay. So now how you can do all of these on AWS? So in AWS we have a breadth of services around machine learning, and we divide it into actually 3 different layers. And this image we have taken from our reInvent conference, which happens every year in Vegas. So this was from the last reInvent 2019, and this is our CEO and DJC. So if you look at it, we have in the lower layer, we have lots of deep learning containers and virtual machines or images which any engineer can use, and we are going to see that in a moment. They can use these images and they can deploy, build their model and train their model on those containers or virtual machines. And the beauty of this is all the frameworks like TensorFlow, PyTorch, MXNet, all are built in there. So you don't have to set that up of your own. You just have to get in and start writing the code. Okay, and then also we have something called SageMaker, and in SageMaker, everything is again pre-configured, but you don't have to start from the scratch, right? So if you are new to machine learning or intermediate to machine learning, you can go and start using the algorithms that we already have, and you can also build your own model, train your own model, and deploy it. Right? So we in SageMaker, what you get is you get an endpoint. So you can do the inference on your endpoint. So endpoint is nothing but HTTP URL, and which you can integrate with your application. Now, when we talk about the deep learning AMI or images, Amazon machine images, these are nothing but EC2 machines. So EC2 is nothing but our virtual machine. We call it as EC2. So you can use any of the deep learning AMI, and you can use that whole system, which will have its own GPU and CPU. You can use the whole system dedicatedly for training your model. Also, you can also use deep learning containers, which are again pre-installed, pre-configured with all these frameworks. So just in case you are not aware of EC2 instance, EC2 instances is our service through which you can create a virtual machine on the cloud, and it you can pick any of the configuration. We have many different types of EC2 machine. You can pick any of the system based on your need. And once you do not need that system, you can always dismantle that. And AMI is nothing but the image. Basically, you can think of it as a just like how when you buy a new PC or server, you put operating system in the form of ISO, right? So you can think of AMI is something like that, but it is much beyond that. So because AMI, you can pick the right AMI. So now in the demo, I'll show you how you can create a deep learning AMI. So it will contain everything. It will contain the operating system, the binary packages, frameworks. You just have to pick up the right AMI and get started with it. So deep learning, AMIs, as I just mentioned, it comes with its own CPU and also with GPU. And all of our systems will also have NVIDIA CUDA support. So you can use the CUDA API to talk to the GPU and train the model on the GPU. Okay, so these are the few of the frameworks that we support. We keep on increasing the support, but these are the frameworks that people generally use in the day-to-day work, right? So if I just take an example of PyTorch, PyTorch is one of the latest, I would say, framework in deep learning. So if you are working on PyTorch, there are multiple ways that you can leverage PyTorch on AWS. One is using a Jupyter Notebook, another is using deep learning AMI, and the other one is using SageMaker Estimator. So the SageMaker Estimator is a high-level API where you will not get a dedicated system or virtual machine, but you can do the training on containers, which of your choice, which contains the required algorithm, and you can just train your model. We are going to see quickly how you can create a deep learning AMI so that you get an intuition about that. Okay, so let me switch to console. Let me just discard this. So let me log into AWS Console. So if you go to EC2 machine, or you can just type it here, or you can just scroll down and click on EC2 machine. What you can do is, now I have one machine running, but let me show you how you can create a EC2 deep learning instance. You click on launch instance, and you can search here as deep learning. Okay, and you select here deep learning, and here you can pick any of this instance. So let's say GPU based, and you can pick there are different instances which contains different memory, CPU, GPU, and all of that. You can click any of them, and you can just configure other things like how much storage you need and all of that, or you can just click on review and launch, and you can launch a system by using a key pair. So let's say I just go with this and click on launch. So now what is happening is, I guess I picked up a wrong instance which I do not have permission to. So let me go back and create a one which I have access to. So let me select here, and let's say GPU, and let's say P2 large. And let's click review and launch. So what happened is, I picked up an instance which I don't have access to, because there are lots of very high-end systems and which costs quite a much, and we need to request AWS support. Or you can also do that from your console to increase the limit if you are intended to create an instance which you don't have access to. But once this is done, right, you can click on view instance, and you will see that it will be initializing stage initially. And then once this is done, you will find that the instance is up and running, right? So let me show you how you can log in and see all the framework. So this instance is up and running. So what I can do is I can just copy its full DNS name, and we can do an SSH, right? So I'll just copy this. Okay, and I'll do an SSH. And another way to do it is you can just click on connect, and you can copy this whole path, okay, which is nothing but the PEM key and the username, right? So let me open my CLI and let's log in. Okay, so now that you have logged in, one thing that you can see is all these frameworks are already loaded, right? So you can just click on, select any of these. Like let's say you want to run with PyTorch, so I can simply copy this line, this PyTorch with Python 3.6, and click enter. And now I am into this virtual environment, right? So everything is configured and up and running. And if you want to see the GPUs, we can always see that using NVIDIA SMI CLI command, and you see that there is a Tesla system here, right? So now you can, open Jupyter Notebook from here. So let's try to do that. So let's open this Jupyter. So now, since this is in the virtual machine, if I want to open the Jupyter in my laptop, I need to, you create an SSL tunnel, which I have already created beforehand, but it's just like a simple tunneling where it will just do the port forwarding for us. So and let's try to open this in our browser. So this is in my laptop, and that machine is running on the cloud. So if you see, now I have come into the same machine, the EC2 machine, which is running behind, and this is the Jupyter Notebook image. So now if I go to, so if you see, there are a lot of tutorials available by default when you create a new instance. And if you go to tutorial, you will find PyTorch, TensorFlow, and all of that. You can explore them. But I'll quickly show you a small demo. I've uploaded it to beforehand. So I'll not go through the whole code. It is a very basic one. But I want to show you that how you can use the CUDA device using PyTorch. Okay, so this is basically a Titanic dataset. which contains all the passenger details. And the idea about this deep learning model is we need to figure out, build a model so that we can predict that a person is actually survived that accident or not. Okay, so based on all this information like name, which cabin they were in, which class they category in the ship they were in, and all of that. So we'll not go through the whole code. We don't have enough time, but what I want to show you is how you can use the CUDA GPU when you are training. So this is how you can do this. So you can use the torch.device method and check for CUDA. Right. So this is the device that you have, and we already know that it has a CUDA device, right? So you can use a PyTorch package to define that device. And once that is done, you can always create your tensors using that device. So what you're doing here is you have this X-train data, which is nothing but the input feature. If you remember that X1, X2, and Xn, so all these are stored in this this data set, like X-train. And this is the data which we will be using for training. And now when you create a PyTorch tensor, you just have to specify that use this device. So if the system is having a CUDA device, it will be using it, right? So this is how you can make use of GPUs. And later on, if you check this variable xtrain underscore dot device, you will find that this device type is on CUDA. Right, that means that you are running whatever operation that you do on this particular variable xtrain underscore, it will be executed on the CUDA device, right? So and then other things are completely similar, like how you build a model or train a model on PyTorch or TensorFlow, on any of this framework. But this is how you can easily create an EC2 system with a deep learning AMI or image, right? So let me go back. Just 1 more minute. So now CUDA comes with different versions. So you need to make sure that which version you are using and which are the frameworks supported by that version. So we have CUDA 10, CUDA 9, CUDA 8. So depending on which framework you're using, you have to pick the right CUDA version. And once you know what is the CUDA version that you should have, then you can pick the right AMI and go ahead with creating a new EC2 machine, right? So this is very important as long as the using GPU is concerned. Okay. All right then. So that's all I have today to discuss about how you can run your deep learning model on AWS. We did not discuss all of the various possibilities, but we have just seen that how you can make use of deep learning AMI on AWS to build your deep learning model. So please keep in touch. This is my LinkedIn ID. If you have any queries or if you get stuck anywhere while setting it up for your training, please feel free to reach out. And we did not discuss about SageMaker or Jupyter notebooks, etc., which are very rampantly used by machine learning community and developers across the globe. If you face any issues or if you want to learn more, reach out to me. I'll be more than happy to help you. So that's all from my side. And for more information, you may like to explore this website. It's a fantastic URL, ml.aws. So there you will find lots of training material. And in fact, we had a university called Machine Learning University at AWS, which was only for employees. But I guess last year or before that, I guess, they opened it up for everyone. So now you can get all those resources, trainings on machine learning, not only specific to AWS, but in general, if you want to learn about machine learning, deep learning, computer vision, and all of that, this is a good place to be in. Okay, so with that, I would like to say thank you so much for your time. I look forward to your questions on LinkedIn if you have any. And thanks for attending this session. Thank you so much.